Welcome to page 2 of your SBAC Interim Review for 8th grade. If you haven't seen page 1 already, go back and find the other video. I'm labeling them Math8 SBA, page 1, page 2, so on and so forth. This is for Miss Agapov, Miss Allen, Mr. BR, or Mr. Dixon's math classes. Make sure while you're watching these videos that you are not just watching them, but you're really listening carefully for the mathematics involved, taking notes, asking someone questions, not just copying what's happening on this page. That's not going to be really useful for you as a learner, but rather listening and understanding what's happening is going to be the useful part here. So standard 8.4, this is the second page. Construct a function to model a linear relationship between two quantities. You need to find the rate of change, initial value of a function, using either points from a table or a graph, and also interpreting that rate of change in initial value in terms of the situation it models. So looking at determining the slope and the y-intercept in a graph, well, the y-intercept is the starting value, or when x is 0, what is y? That is your y-intercept. And the slope of a line is the rate of change between 2 points. So for example, starting at, let's say this is $2, going up to 5 would be $3 for 1 day. So that's a change of 3 for every 1. So the y-intercept is the starting value, and the slope is how much the values are changing between 2 points. So 3 over 1 is the change in y over change in x. That is the slope. We'll use that same information on this entire page. So my slope is 3, or you can write it as 3 over 1. Those are equivalent. And my y-intercept is 0, 2, but your teacher will accept 2 as your starting value. Question 2, determine the slope and y-intercept of the line that represents the table below. So this is just like the graph. I have 1 point, 2 points, and then decimals in between, decimal point values in between. These are 4 distinct points that are given, not on a graph. So we can still find the slope, change in y over change in x. So this is going down 3 from 10 to 7 for every plus 1. So that is the slope of negative 3 over 1. Now this is supposed to be a linear equation, so let's check that it's still going down 3, yes it is, for every up 1, yes it is, and then last one down 3 for every up 1. Yes, so that is my slope. Now to find my y-intercept, remember the graph, 0, y, whatever point has an x value of 0. So this point has an x value of 0, so that must be my y-intercept. So we're looking on a table and a graph for the same thing where x is 0, what is y? So my slope is negative 3 over 1, or negative 3, and my y-intercept is 0, 4, but you can just put the y value is 4. Determine the slope and y-intercept of the line through these 2 points. Then write an equation. So this is a multiple part question. First of all, you have this x value and this second x value, because there's 2 different points. And then you also have this y1, or first y value, and this second y value. So these are 2 points, just like we had points in this table, just like we have points on this graph. We can find the slope similar to what we did here. So we want to find the change in y over the change in x. Change in y is found by finding the distance between the y values, or subtracting the 2 y values. And finding the change in x is found by finding the x value minus the other x value. So let's actually use the values we have here. y2 is negative 4. Take away, or the distance between that and the other y value, which is 10. And my other x values, x2 is 4. Take away this x value. I'm going to put it in parentheses because I've got a minus negative. I want to keep track of that. So we can find our slope by finding, just like we did here, change in y over change in x. Change in y over change in x. Be really careful here when you do your calculations that you don't mess up those negatives. Negative 4, take away 10. If you're working on negatives, really think about a number line. Here's 0. Negative 10 is over here. Let's actually start with negative 4. Let's do it right here. 1, 2, 3. I'm at negative 4, I need to take away 10. So negative 4 minus 10 means go this direction. Minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that moved 10 units further into the negative. We're at negative 14. Negative 14 over, same idea of a number line, we're at 4. 1, 2, 3, 4, minus negative 3. Taking away the opposite of 3 is the same as adding 3. 1, 2, 3. Notice I'm modeling two different ways you can show work on a number line. Just whatever way works for you. 5, 6, 7. So 4 take away negative 3 is 4 plus 3, which is 7. Well, I can simplify that. Negative 14 over 7 is the same as negative 2. So there's my slope. My slope is negative 2. Well, now I need to find my y-intercept. Now, I could find it by looking at my graph. I could find it by looking at my table, but I don't have anything to look at. My points I was given are not y-intercepts. The x's are not 0, so I have to discover or figure out what my y-intercept is. So let's do that. I've got an equation I can use. Y equals mx plus b. Well, my slope, or m, is negative 2. X plus, well, I don't know what b is. That's my y-intercept I'm looking for, so I'm going to put b. The reason I can use this is I have my slope, and I have a point to use. I can use either one of these points to make this equation true. I can use this x value and this y value, and the only unknown I had left is b. So let's put in this x value, which is, let's use, it doesn't matter which one you use, so I'll use this one. X is negative 3. I'm going to substitute x for negative 3, and y is 10. So I'm going to now use my equation with my variables now solved for and my constants figured out. I can do this equation fairly simply. 10 equals negative 2 times negative 3 is 6, plus an unknown b, I don't know what it is, but I can solve for it. Something plus 6 is 10. Take away 6 on both sides, or you can do that in your head. You know the answer is 4. So my y-intercept must be 4. So when it asks for me for my slope, I've got that right here. I found my slope here, and I found my y-intercept here. My slope is negative 2 over 1, or negative 2. My y-intercept is 0, 4, or I can just put 4. My equation that I started here now has a b value that I know. Y equals negative 2x plus 4. So this standard just has you find slope and y-intercept in many different ways, so keeping track of your understanding of what those values are. Next standard, compare rates of change in linear relationships in different scenarios. So remember, rate of change means slope. So in order to find a rate of change, we have to do what we did above, is find the change in y over the change in x. Now I did notice before when this interim was given, students did this in a lot of different ways. I'm going to solve this in a way I saw most students thinking about it, and then I can back up if I need to and explain the way that traditionally it would be done. Aaliyah had 60 candies after 8 houses. She is collecting 3 candies per house. How many candies did she start with? Well, I had a lot of students do this. Let's say that x is houses, and let's make a table. Let's say that y is candies. I saw a lot of students say, well, 0 houses, 1, 2, 3, 4, 5, 6, 7, 8, and they worked backwards. The only thing they knew was it was 60 candies after 8 houses. So they put in 8 houses was 60 candies. They knew that information. They didn't know any of these, but they had the rate. The rate was 3 candies per house. That's 3 candies for every 1 house. Well, that would mean that if I went backwards in time and went to the previous house, I would have to go back 3 candies. So I must have had 57. So I'll say that one more time. Moving forward in time, if I was at 7 houses with 57 candies, and I'm getting 3 candies for every house, 3 more candies would be 1 more house. So they just kept working backwards until they got to 0. Because remember, what we're looking for is how many candies did she start with? That would be at 0 houses, how many candies would that be? The only mistake I could see happening here in this method would be just not subtracting by 3 correctly, so just be really careful. Work backwards and then work forwards just to make sure. So I'm just going to keep subtracting 3. 54, 51, 48, 45, 42, 39, 36. Remember my advice to work forwards again? Let's make sure. I find it easier to add on than I'd subtract. So plus 3, yes. Plus 3 again, plus 3, plus 3, plus 3, plus 3, plus 3. Looks good to me. So how many candies did Aaliyah start with? She started with 36 candies. Same exact method over here. Actually, you know what? I could show you that same method, but we already talked about that here. Let me show you the other method for figuring out Isabella's start. So we know this is a linear equation. It has some starting value and it's going up in the same amount every time. It has a constant rate of change. So I know my equation would look like this. Y equals mx plus b. Well, it said that she's collecting, or he is collecting 2 candies per house. So my slope or rate of change would be 2 candies per house. And then it also tells me that I have a known value. I know that for 10 houses, I have 75 candies. So that must be my x value. And that must be my y value. So I'm going to substitute into my equation those 2 values. My x value is 10. My y value is 75. And notice the only thing I have left that's not known is my b value. So I can now figure this out. Another way I've heard a student say this to me is, oh, so it's 10 houses, 2 candies per house. That's 20 candies I got total by going from house to house. But I know I have 75. So if I take away the 20 candies I collected, I will get back to what I must have started with. So that tells me I started with 55 candies. So that means that he started, whoops, my handwriting is really bad right now. He started with 55 candies. How many will each of them have after 20 houses, and who will have more? So she started with 36 and got 3 candies per house. Notice that this method is pretty frustrating, probably, going from 8 houses up to 25. I mean, it is possible. You can keep adding 3 until you get from 8 houses, 9 houses, 10 houses, counting by 3s till you get to 25. I've seen students do that. It's not very efficient. It takes a lot of time, but it does work. Instead, let's try this method. I know that this Aaliyah person had 3 candies per house, plus her starting value was 36. I know that Isabella had 2 candies per house, but started with more candy, started with 55. Now the nice thing about having an equation is it wants to know what happens after 25 houses. That's just a substitution. Y equals 3 candies per house multiplied by 25 houses. And that will figure out my total, because all I have to do is say that's 75 candies, 3 times 25, plus the 36 I started with. Again, I've seen students kind of do this a different way, thinking about, okay, 3 candies times 25 houses, add on my extra, however you want to think about it, this is the way you could show your work. That makes 111. So that means 25 houses, that person has 111 candies. Let's check this one. Y equals 2 multiplied by 25 houses. And let's figure out how much that person has at the end. 50 candies collected along the way, plus the amount that they started with. Y equals 105. So that means that after 25 houses, that person only has 105. So who has more? Well, this person Isabella has only 105, and this person Aaliyah has 111. So we say Aaliyah will have more. I know because 111 candies is more than 105. All right, so this entire page is about knowing what a y-intercept and a starting value, what that means in the context of a problem, and what a slope or a rate of change means in the context of a problem. Being able to calculate that regardless of what you're given. A story, an equation, a table, 2 points. Make sure you watch the other videos, go through the other pages, make sure you're taking notes and asking questions.